recall, okay, or remember. A salt is the product of an acid and a base reacting. Okay. This second line is something I want you to remember well. This property. If the salt dissolves in water, it will ionize completely. There is no such thing as a salt dissolving in water and remaining unionized. Okay, got that? That's quite crucial for you to remember. Okay, so sodium chloride aqueous, when it dissolves, you get Na plus and Cl minus aqueous. Okay. Ammonium ethanoate, sodium ethanoate, CH3CO Na. Okay, so you get CH3CO minus plus Na plus. So this also ionizes completely. Okay, ammonium chloride, NH4 plus Cl minus. Now, the first step in dissolving is this ionization. Subsequently, there can be a second step, which is the hydrolysis. Okay? And this hydrolysis may result in an acidic or alkaline solution. Okay? Now, this doesn't always happen. You need to know. This is what this whole section is about. Knowing what can happen and therefore what is the result. Okay, so how do we know whether an ion undergoes hydrolysis? What is hydrolysis? Okay, so the easiest case is a salt that forms from a strong acid and strong base. For example, HCl reacting with NaCl, which you get Na, sodium chloride, Na plus, Cl minus plus water. All of you know this reaction, or you should know. Do all of you know that NaCl is your table salt that you add when you're eating cookie? Yes? I'm pausing because I'm feeling some signs of a heart attack. Would you believe that every year I've taught at RV, right? I've seen students write in exam the first equation, the reverse of it. They will write NaCl plus water gives me HCl plus NaOH. Without fail, they'll write that. So basically, from salt water, you can get acid and sodium hydroxide. Okay? You can laugh now. It's not funny when you write exams. Okay, so Na plus, Cl minus are only hydrated. They will not undergo hydrolysis. Which is why your table salt does not taste salt. It just tastes salty. It doesn't taste bitter. It doesn't taste sour. Okay? In contrast to something like, say, you take like baking powder or baking soda, it will have a totally different taste. Because that will be an example that we come across. Okay. Now, so hydrated means the ion is surrounded by water molecules. So I think in our notes it will become under chem bonding and energetics. We get these diagrams. Okay, you have an ion dipole interaction. Now, the pH of such a salt solution is 7, is neutral. Okay. Now, this hydration, when ions are attracted by water molecules via this ion dipole interaction, this is a physical change. Hydrolysis is a chemical reaction. So, and it will take place between it involves the acid-base equilibrium. So for example, you have something BH4 plus H2O. So that can hydrolyze to give you B plus H3O plus. Okay, likewise, A minus plus water can give you back HA plus OH minus. Now this is similar to what you have seen before, these two equations, except they are written as the reverse. You have seen HB plus H2O to give you BH plus water. Okay, you have seen HA plus OH minus to give you A minus plus water. Okay? Now, let's take a closer look at this. For example, you have ethanoic acid, which is a weak acid, reacting with a strong base. Therefore, you get CH3CO minus plus H2O. Okay? This is written as a single arrow. It generally is irreversible. However, okay, in water, the CH3CO minus can react with water and get back the CH3COH plus OH minus. Okay? Now you take a bit of time to think about this. Okay, and this is a two-stage thing. The first reaction, for example, let's say you're doing a titration. The first reaction will occur first. Okay, and then if you add stoichiometric amount, all of it will react. Okay. However, once it reacts, then you have the product, the CH3CO minus. Okay. Then that product can react with water. There will be a lot of water around because it's a solvent, and then it will form CH3COH plus OH minus. Okay. Okay, so the Na plus, it comes from a strong base, which is sodium hydroxide, sodium oxide. So there's no hydrolysis. Okay, now because there is an excess of OH minus here, this pH of this salt solution, if you make it, will be greater than 7, which is alkaline. Alright? Okay? Okay, so the weaker the acid, the stronger the conjugate base, and the greater the extent of hydrolysis. Okay, and the more alkaline the salt. Okay? Okay? Okay, so now HCl plus ammonia, you're getting ammonium chloride, weak base as a strong conjugate acid of ammonia. So you will undergo hydrolysis in water. Okay, so you will get H3O plus. The chloride comes from hydrochloric acid, which is a strong acid, so there's no hydrolysis. So pH is less than 7, which is acidic. Alright? Okay. So weaker base, you get stronger conjugate acid, pH plus, greater the extent of hydrolysis, the more acidic the salt. Alright? So this is listed there. Okay, so what happens when you get a weak acid plus a weak base? Okay, so you got strong conjugate base, strong conjugate acid. Both will hydrolyze. So the question becomes, is the salt acidic or alkaline? Which ion hydrolyzes to a greater extent? Okay? So, if the Ka is larger than the Kb, then okay, A minus is relatively weak, BH plus is relatively strong. Okay, so OH minus is low, H3O plus is high. Alright? And then therefore it will be acidic. Okay? The example that I gave you in there, it happens, it's a coincidence, right? That the particular thing is big. The Ka and the Kb are equal. Okay, and therefore it will be neutral. Now, it is unlikely, if they give you something like this, they have to give you the numbers. You are not expected to memorize which one is, all these numbers, and see which one is stronger or not. They have to tell you. Okay, and then you have to calculate. So far, they have not done this sort of thing. Okay, the examples are far easier than this. Okay, so this part is relatively unimportant. What is given in your notes is sufficient, so I will move on to the example. Okay? Okay. Now, you do have to remember what the strong bases and strong acids are. So, for example, potassium, K plus comes from a strong base, potassium hydroxide. So, no hydrolysis. The propanoate, the organic one, will be a weak acid and therefore undergo hydrolysis. Okay? Therefore, there's a dative bond formed between the O minus and the H. That will be your equation. Okay? So, you have excess of OH minus. Okay, so CH3CO minus undergoes hydrolysis to give you OH minus. The salt is the alkaline. Alright? Okay, so you have that. Let's look at sodium carbonate. I actually have an easy way of remembering whether the salt is acidic or alkaline. If it is a weak base, then the salt will be acidic. If it's this is my own personal way of remembering, it's not a way to explain. If it is a weak acid, the salt will be alkaline. Okay? That's just a way of remembering it. You can get sodium carbonate at home if you have baking powder or baking soda. Baking soda is sodium hydrogen carbonate, so you can, either one will work. If you can go put some water in it, then you can go and taste it. You will taste very, very bitter, which is an indication that it's an alkaline substance. Alright? Okay, salt solution is alkaline. Can I show you the next one? Alright? Okay? Okay, don't take photo. I'm going to change slide already because I want to finish this example. Or you can watch a video. Last 2 minutes of video. Okay? All at least got a representative to take a photo. 3, 2, 1. Okay, I will stop here because I need to go for the other lecture.